One of the common terms or terminologies we use in the EP lab during diagnostic EP studies is AV node or nodal echo, also known as an echo beat. Now, do we know what that means or what that is? Remember what is required for AV-NRT to occur, right? So the basic requirement is what is called dual AV nodal physiology. And how do we see that? Now, in order for that to happen, we need two pathways. Namely, you need a fast pathway and a slow pathway. In which case, then the fast pathway has a long refractory period, whereas the slow pathway has a short refractory period, right? Now, how do we then prove dual AV nodal physiology during an EP study? Now, we see that as we give extras, when you do extra stimulus pacing. If you look at the screen here, we are pacing from the high right atrium. So this is our drive train here, and it's labeled S1, S1. Remember that the drivetrain it's the one that goes at a constant rate, whether it's 600 milliseconds, whether it's 500 milliseconds. And then after that, you then give an S2, which is an extra beat. You can see the interval is way shorter than our S1, which shows that this is an extra beat that we brought in quite closer. Now, what we are going to see as proof of dual AV nodal physiology is that after introducing this extra beat, you're going to have an AH prolongation, right? So you can see here, I think that's your A, your H, and your V. So now you have your A, and there's your H somewhere, and your V. Now, that proves that, remember, you have a fast pathway, slow pathway. Normally, after you give an S2 or an extra beat, that wave front comes in and blocks in the fast pathway, because the fast pathway is still refractory in that moment, and therefore it chooses to conduct down the slow pathway. And because it's conducting slower in the slow pathway, you have this long AH interval, because we have blocked in the fast pathway. Then it comes down here, conducts to the V, but also at the same time conducts back up to activate the A again. Now, if you look at our CS channel, we have both A and V on top of each other simultaneously, which is proof that we have V and A activation simultaneously. So essentially, this is the wavefront echoing back to the atrium to activate the atrium retrogradely. Hence, echo beat.